right now. And just a quick reminder, if you have any questions at all, please put them in the Q&A box for a question and answer session after the presentations. And we will be sending out a follow-up email with all of our resources, slides, and the recording within a few days after this presentation. So with that, I'll hand it off to Mary for a couple of quick introductions.
Thanks, Diego. Welcome, everybody. My name is Mary Weiner, and I do the energy efficiency program for Holy Cross, and currently kind of dabbling in electrification, which is becoming quite the hot topic. And that's why we're doing all these workshops so that everybody can get a better understanding of what a heat pump is. You have one already in your house, and I'll let Dave, if you haven't already guessed what it is, I'll let Dave clue you in on what heat pump you already have in your house. So Dave, like he said, he's actually in the Front Range in the Boulder area, and he used to own a geothermal business, and then kind of got into sustainability and has a master's degree, and just has really thrown himself into this heat pump revolution, as we will call it, or evolution. Who knows? I think it's an evolution, right?
Yeah,
of heat pumps.
more of an evolution.
More of an evolution. They've been around since the 80s. So it's so great to have him back and doing this presentation for us. And then right after, so we'll hold questions, because then right after Dave's going to talk, Tim, are you sitting in St. Louis again?
I am.
So 28 years now, right? Do I have the years right with Ream?
Correct. Right.
Yeah.
On.
So
Good
Tim,
memory, Mary.
oh my gosh. Yeah. So Tim has been with Ream 28 years, and there are, there's heat pumps for heating and cooling your house, but did you know there are heat pumps that are the most efficient way of doing domestic hot water? And we're going to have Tim kind of go over what they look like and how to put them in either a new construction, or you can actually retrofit those into existing homes. So we'll go with Dave first, and then Tim, and then we'll do all the questions. So we already have some questions coming in, so we will keep those till the end. So Dave, take it away. Thanks both of you for being here.
All right, welcome everyone. And there's myself and Tim. So today, my part of the talk is about heat pump centric HVAC systems for new homes. But if some of you have existing homes, a lot of this will be applicable, and there's previous presentations you can view online. And usually we have a very wide audience. So we'll start a little bit about how heat pumps work, just a one slide little intro. We're going to talk about the dramatic improvement of heat pumps. In fact, that's really why we can talk about them here. Just all the changes over the last 15 years, amazing. And then we'll talk about the two different kind of heat pump systems. And now what's great, you're building a new home, and in the past it used to be, well, I put in air conditioning, I put in ducts, I put in a heating furnace, or I put a radiant heating, and that's it. But now you've got lots of different strategies, a lot more options. That's what's exciting. Talk about cost, because that's obviously very important. And then we'll talk about how do you work with your builder? How do you get a good system? Not only just a heat pump, but just a good heating system in general. And then this field is evolving so fast. Mary's got so many things going on every year at Holy Cross and Walking Mountains and all the other groups up in your part of the state, that some great programs. So let's just talk real quickly about a heat pump. Basically, a heat pump, an air conditioner is really a one-way heat pump. So heat pumps can heat in the winter, cool in the summer. And it's a similar thing. Outside, you have a unit that can look like a standard air conditioner or a little bit different. And what happens is you've got the beauty of a refrigerant. So refrigerant is an amazing liquid or chemical that really absorbs heat, loves to change state, loves to give up heat quickly. So what happens, it comes in really cool, and it's in the out, there's a coil in here, obviously, and very air's blowing by it. And what happens is this, what was liquid refrigerant, absorbs the heat and becomes a gas. And it becomes a warm gas. And then it goes into a compressor unit. So within here is a compressor unit, because this is not, no matter what the outdoor temperature, this is not up to quite warm enough to warm your house. When it's really cold out, this will be a little cooler. When it's 50, it'll be warmer. So we have to compress it. So we do have to add some energy. We get this up to about 110-degree refrigerant gas. It comes in the indoor unit, be it like an air handler or mini split system. There's a coil, air goes by and it heats your house. One thing I didn't mention up here, I should mention that is, don't think of this as moving temperature. It moves heat. So even when it's cold outside, there's still lots of heat in the air. It's just not as concentrated. So if it's minus 460 Fahrenheit, you have no heat. But minus 10, there's lots of heat. 10 degrees, there's tons of heat. It's just how do you concentrate? So that's the fundamentals of a heat pump. So let's talk about how they've improved and really why we can talk about them as a great tool for your heating and cooling your home in 2022. Around 2005, I'm going to say, it was kind of the birth of cold climate heat pumps in North America. There have been some work in Japan and in Europe about it, but a lot of people who worked in heat pumps said there's really no reason that heat pumps can't work in cold climates. I mean, they're in Florida, they were in Oklahoma, mild climates with a little bit of heating. It's like, we should be able to use this technology. So there's a lot of efforts, mainly in, all right, how do we get them to defrost and they ice up? How do we get them work when it's really cold? A lot of research, a lot of improvements. And then from 2012 to today, they're installed all over North America, New England, the Midwest, Canada, Colorado, Rocky Mountains. So this is not like a newfangled thing. It's out there, they're established. Well, what did they do to be able to make these better? There was basically every component in the heat pumps the engineers could work on. So they improved those compressors. I talk about the real thing that uses energy. They made inverter controlled, smarter compressors. They figured out how to do defrosting better. They made the alloys in the walls of the heat exchangers better, so that refrigerant can absorb heat faster, give up heat faster. The blades of the fans were better, and one of the biggest things was computer controls between indoor units and outdoor units. And I'll talk about the indoor units in a second. Basically, so it says if it's 50 degrees out and I need just a little bit of heat, I'm going to run my outdoor compressor a little bit. I'm going to run my indoor fan a little bit. In the past, it was full on, full off. It was like, I need to drive my car 30, but the only option you have is to go 60. So that was really, so all these things combined made for massive technology improvements or performance improvements, really. This slide shows, this is the outdoor temperature from 0 up to 60, 70 degrees, going from left to right. And then the up on the vertical is the amount of heating energy that's required to heat a house. And the green line is a sort of a standard size house, keep it at 70 degrees. And it increases linearly up as you go colder. This is before this revolution or evolution. The blue line is what heat pumps used to do, which worked fine in Oklahoma or Texas or somewhere it doesn't get very cold, basically down to 30 degrees. The heat pump could heat the house fine. It matched how much you need, but it was short. So over the last dozen years, 15 years, this was the improvement. All of a sudden, the heating capacity they worked on, they said, we need to get the heating capacity when it's cold equal to the heating capacity when it's warm with the heat pump. That's this orange line. So it stays pretty steady. So this big gap between what I need, what I could do, goes away. And you'll say, well, Dave, there's this little triangle here. And you're right, there is a little triangle. This doesn't represent very much heating compared to all this need. You'll see that in a different way in a few slides. But so inside the indoor unit, there's a little bit of electrical resistant heating, which can help supplement in that. Or in some cases, if you have a gas furnace or you decide to do that, that little bit of gas will do this part. So that's one. That's improvement one. Improvement two was defrosting. Here's another improvement, how efficient they are. And this directly relates to decreasing cost to heat your home with a heat pump. So this is around 2012 up to 2020. You know, we're 2022. I think the highest one still is. This is HSPF, heating season performance factor. How well does a heat pump heat your house? How efficiently? The higher the number, the better. 8 is twice as good as 4. 12 is twice as good as 6. So they were around 8.2. Now present day, when you go and look at all the manufacturers' websites, most of them, whole climate heat pumps are right in here, 10 to 11 HSPF, which is about a 28% improvement in efficiency. So think of that as a direct 28% operating cost reduction. The best one's around 13. You'll notice they go up maybe a point every year. So I think the next version, which is coming out in 2020, 2023, will probably be another point up. But this is where most of your choices are. So 4 things: efficiency, defrosting, higher capacities below 30, and the ability to provide heat below 0. Like, they don't just turn off at 0. They can go -10, -15, and still provide good heating. So you're building a new home, and there's a couple ways to think about heat pumps, sort of core strategies. And I know some of you are asking about radiant, and we'll get into that when you're thinking about homes with radiant or without, how to integrate things together. Here's a heat pump system, heat pump with an air handler. So just an air handler. There's no natural gas. It's just basically looks like a furnace. And inside here is electric, a little bit of electric heat for that little triangle. And you connect it to ducts, and it heats and cools your house. Over here is similar strategy, outdoor unit. The difference is you have a furnace in here, but basically you're using the furnace as the blower and a way to transport the heat for almost all the time. You might use the gas a little bit when it's super cold. So 2 core strategies with ducts. The other one, though, which is, it's been around a while now, probably about 25, 30 years, but it's really, in terms of evolution of heating and cooling, it's really the new fundamental thing in the blockers. You've seen them as mini split, or they're called ductless. Now, multi-zone mini split is where the real advantage is, because one outdoor unit, you can have 2, 3, or 4 or 5 indoor units. Typically, you're going to have maybe off of 1 outdoor, 2 or 3. Each of these zones is independently controlled. Little diameters for run. So think about when you're building a new home. It used to be, and you work with the architect or the builder, you need lots of duct space, relative. In the basement, you need it going, you need a vertical. So now, basically, I don't need any of that. And I've got a lot of indoor options. I have many styles. The next slide you'll see I've got many options of how I want to do it. So you can do the aesthetics great. So here's the classic unit on the wall. And just so you know, a lot of the manufacturers have jazzed these up. They have some that are shiny black, some that are curved, some that are mirror. I mean, they're trying to make them look aesthetically a lot more appealing. You've got options to go with these low wall units. In some cases that might make sense. But really, a couple nice things here are, I've got, instead of this wall unit, I can put a unit similar, but it's flat against the ceiling. And these are usually kind of at the edges of the room. They fit between the joists, and they'll be able to heat a whole room. They'll blow air in this kind of pattern. Another one that's really great in the middle of the room, and this kind of evolved from the commercial world, is you've got air going out in 4 directions. And this has the ability to change how the air flows out, depending on if this summer it's warm and you want cool air near the top and it floats down. If it's winter, it sort of creates a mixing. So these are great options. 2 other ones, a slim duct, so only about 9 inches. So normally this little air handler in here, it's called a slim duct unit. It's about 9 inches by maybe 18 by 18, roughly. So this thing can fit in the attic. It can fit above a closet. It can fit above a bathroom. And it can do, the nice thing about it is, just have grills in your room. But also really a big advantage is this can do like 2 bedrooms that are adjacent to each other. So you can have, like, this comes out and it splits, and I can have a supply and a return. So very, very flexible. And finally, it's just over the last couple of years, some of the manufacturers are coming out where it's a air handler. So this could do like a whole floor with the old way. You could put ducts and do sort of the 2nd floor or the 1st floor underneath, but also you can combine it with these units. So now I can say, well, okay, second floor, I want this, I'll have these do 3 rooms, and then the main floor, I might do this and this. So you've got all kind of ways to do it to fit with the aesthetics of your new home. Now, one thing I got to bring up, which is really important, building new homes now, we want to build them really tight, really well sealed. We don't have to unnecessarily heat and cool air. It's really important that you have a great shell. But that means a couple things. There's really no fresh air getting in and out. And especially now also when we have these smoky situations in the summer or really hot, really cold, you're not going to do the old thing. I'm going to just open the windows to get fresh air, or in the basement where there's no windows. So you got to have a fresh air system. It's a heat recovery ventilation system. And what it does is it brings in air from the outdoors into a box. This box is about, some of it depends on size, 18 to 24 by about 4 inches by about a foot. And so in here, air from the outside and air from the inside cross inside a heat exchanger, which has like a metal accordion, and it exchanges some of the heat. So the air coming in now isn't really cold. It's gained maybe 20 degrees or more. And it goes in and mixes with the air in your system, and it gets heated up. So this saves a lot of energy, but yet gives you fresh air. So you really need to think about fresh air systems. And I'll talk a little bit of how they integrate in. It's called a heat recovery ventilation system. So I think one thing you want to start doing, you're looking at your house and you're saying, okay, but what's going to be my best strategy? And there's a few fundamentals you just want to think about. So you're going to think about all the sections of your home. And I think you need to think about your past homes, because I think everyone has had a home where part of it is too cold or too hot, or it isn't heated right, or doesn't have the right thermostat. So think about that. What sections of my home, where do I want thermostats? Where do I want like really good control? And where in a room, maybe if it's a couple of degrees off, not so. Where do you want cooling? I talked about fresh air. People on the call, radiant heating, they have it. But if you're putting in a new home, is it a priority? Remember, it is the premium type comfort system, but the other stuff's catching up. And one of the big reasons is this great shell that we have now. I mean, walls when used to be cold and would feel cold, but now you don't have that effect. So a big change. And how important is it to reduce or eliminate pollutant emissions from your home? In other words, you will not want to have gas in it. That's a priority for some people. So you got specific questions to consider, and I mentioned them. So how many zones? How many thermostats? Well, you want at least one for each floor. And then you think, well, the second floor, all right, so I want more control from my master bedroom. On the main floor, do I want, is it's kind of where I have a south facing half and it's got big windows, maybe a lot of sun, and the north is kind of shaded and cooler, or is it east west? What are my big rooms? And the basement is a use diverse area. In other words, is a basement, some basements I've seen have a bedrooms, a TV, a workout room, and a laundry room. So you got to think about that. Okay, do I want different conditioning for those? And I'll talk more about simple ways to do basements. But just something to think about. Where do you want your cooling? Does it have to be the whole house? I know in the past, up in the high country, it was like, we don't need cooling. But now talking to folks, it sounds like, you're building a new home. Something most people now want to have in their house. And where is radiant heating inflow important? If we're going to do a combination system to have fresh air, cooling, high efficiency, where do you really want radiant heating? Where does it matter that your body's optimal temperature, your feet are warm, and where not? So what I'm talking here is I'm going to go through sort of 3 heat pump centric strategies, and they go from sort of simpler to middle to more complicated. It's not really, I was thinking it's not really good, better, best. It's just like different strategies. The first one is a whole house ducted heat pump system. You've got cooling as part of it. It's easy to add filtering in that HRV system to the whole unit. It's more difficult to have many zones because you have to plan out the duct system. You've got to do zone control dampers. So you don't have any real neighborhood pollution if you go all heat pump with a little electrical, or it's only for, some hours of the year if you've got a furnace. So it's a low, for those of you who's important, it's a very lowest or the second lowest impact on GHGs. Whole house multi-zone mini split heat pump system. So now this is based, say, I'm going to go with the mini split strategy. I've got all kind of options. Cooling and filtering are included. You can't directly do the fresh air system with the mini units and for most of them. So you just have to think of different ways to do that. That's okay. You've got a lot more zoning flexibility. You've got no emissions and lowest GHG. And then finally over here, you've got, for those of you who are on the call and thinking about the radiant, it's a combos multi-zone mini split and radiant system. So you've got this strategy. You can say, well, all right, I've got areas where I'm going to do cooling and I want these mini splits filtering, maybe second floor. I'm going to have a separate fresh air system. I've got maximum zone flexibility. I'm going to have a boiler into the radiant. So I've got some emissions in there, but think of it as having two really super tools. I've got a radiant I can do things with in the house, and I've got these mini splits I overlay on. So let's talk about each of these and just a little more to think about with all of them. So we got the whole house heat pump ducted system. If you have a one level home, you're going to have one, and it depends how big, but sort of the typical up to 2,500 square feet, 2,000 square feet. You're going to have one unit outside, and you're going to have an air handler in the basement, and you're going to heat and cool the main floor with a couple zones. And you're going to have the HRV hung there, like I showed, and it's going to be fed into the system. Now, the basement is interesting because with well-insulated basements, you hardly need any heating or cooling. I mean, my basement year-round, I work in it, and I don't really have heat in or cooling. But what you can do to get fresh air is you can do a couple small vents in the basement from the main duct system. Not big, just enough to get some fresh air. And really, you're not going to need cooling, and you might put a little bit electrical for comfort. So it kind of depends. Like, if I got a bedroom and a TV room downstairs, they're going to, you can have your HVAC guy figure out, well, the bedroom, I only need to keep whatever, 68. It only needs a tiny bit of electrical heat. You can put a little floor, a little wall deal, etc. Versus the workout. Or if you're doing, and I'll talk about radiant later. Two-level house, you're going to, in the past, it was this deal. I'm just going to put one unit outside. I'm going to run ducts all over. I'm going to run ducts upstairs. Not very efficient, hard to get zoned. So really, in a lot of cases, it makes sense to do two smaller systems. One's in the basement. It's dedicated to do the main floor, a tiny bit of the basement. And then another one upstairs to do the upstairs. And you can easily that way zone them, get comfort, get efficiency, and save space within the house. I'm not going to say you can't have quotes and someone look at one unit to do the whole house, but in general, you're going to want to have a thermostat on each floor. You're going to want to have an insulated duct system. So it's really, I don't say it's a primary way to go. Now the mini split is a little different thinking. You've got the ability to have multiple indoor units on one. And like I said, it's up to 5, but probably typically you'll do 2 or 3 on one. So you've got, first of all, you can work with the architect and say, all right, which rooms do I want this? And you can, if you've got big rooms, you want to try to not have as many of these. You might be able to have one of these units to do a couple big rooms at once. So one outside, you want to have one air handler in the basement to cool the first floor, and you might have one air handler in the attic to heat and cool the second floor. So this is a case I showed you where one outdoor unit, 2 runs up to 2 sort of air handlers to do that. That's one way. You can add more zones. Like you could say, I'm going to have a little system upstairs in the attic, one in the basement, my master bedroom. I want to have a nice ceiling concealed one because I want to have a separate thermostat in there. Or in the main floor, I might want to have my office. I might want to have a little wall unit in my office. So you can start to think about what are the big areas, and then what rooms do I spend a lot of time in? What's the most important? Filtering is a big deal. So now what about a combo multi-zone mini split and radiant system? So the way I tend to think of it is, all right, you really got to think, where do I want cooling? Where do I want the most efficient heating system possible? And so if I think about that, that's where I consider, okay, the mini split is the primary system. And so you say, well, in the second floor, it's the main system. So you can either do a ducted system in the attic, or if you have a couple rooms, you can do little units. So let's look at this second floor. And I'm saying, all right, I want cooling in this. I'm going to have radiant in this house too. So little rooms, I'm just going to put my radiant in here. Because remember, even though you say, oh, I'm buying one boiler, I'm asked to do everything, it's very costly to do zone valves, diverter valves, run the radiant floor. I do the bathroom, I'll do all this. I'll do this with my radiant, and I don't need cooling. I got fresh air, I got fans, I'm cooling. All right, over in here now, on this side of the house, I might say, well, these are kids or guest rooms. I don't know if I need radiant in those. I can hang in here like one of these slim duct units, and I can do these two rooms. They're on the same side of the house, they'll be comfortable. And I can do a tiny little one in here. So I can do this whole sector like that. In the owner's retreat, I clearly want cooling, so I could put a little unit in here. So I've got, and you can decide the option, owner's retreat. If I want to have optimal comfort, I'll put radiant in for the heating of the floor. But I've got my mini splits, and I'll show you one of the next few slides, how you can think about, I use the mini split for most of the year. Like, it's very comfortable. I use it for 9 months of the year. And, set for these zones, which, you might want to keep the heat in the floor most of the year, I'll turn the radiant on the rest of the year. So consider that radiant as your comfort system for the cold months. So now the main floor, you go to similar philosophy. So you've got these slim ducted units and non-ducted that you don't have to have any ducting to take up room. All right. And you can look at the warm side of the house, and you might say, okay, what's the warm side of the house? I've got this side, I've got south, I've got glass, I've got a fireplace. I can just do my mini splits over there. I've got my back side of the house, pretend this is south and this is north. I got my home office, got my dining room. Maybe I'll put radiant in these rooms because they're going to be in the cooler side of the house. And then in here, I'll just do the radiant. So you can think of using these tools. Where do I need cooling? Where do I need fresh air? Where do I need comfort? And then what you want to think about is, how often do you want to run the cooling? Why, the heat pumps are really saving you money. How is that happening? Well, coefficient of performance says energy in, heat out into my house. It's called COP. So propane and natural gas, boiler or furnace, what it is 95. If it's a 95% system, it says it is 95% efficient at burning that fuel and generating heat. Electric heat resistance heat is 1. In other words, when the electricity goes in, it basically goes through all the high resistance, it becomes all heat. Heat pump, as I talked about, 3 units of heat energy for 1 unit of electricity. Now, actually, it varies a little bit over the seasons. In the milder season, where it's 50 out, this number is near 4. In the colder season, this number might be near 2.5. But typically over the year, it's around 3. So it uses only 1/3 the energy of these other systems. And so you're going to save money. You're going to save versus electricity a lot, 65 to 70% versus old all electric. Versus propane, because some of you are going to build a new home and you're not going to be near gas, or you're not going to be, it's going to save you a ton there. Now with a natural gas boiler and radiant combo, if you use the heat pumps correctly, you're going to save versus just a pure heating system. And now a heat pump versus the old, like say you say, all right, what's a heat pump versus all natural gas boiler? In the past, they weren't close. Now it's a little bit more, a little bit less, depending on the pricing and winter pricing. And I'll tell you, a little bit more, a little bit less for a typical house means about $20 difference either way. So, and you know, this is last winter's prices, gas is going up. So probably this year, the heat pump might have a little bit of edge. But now here's the beauty with this combo system. Look at, this is the climate of Eagle. And I'll tell you, for all these months from almost October all the way to into February, March, if you have radiant in some rooms, but you've got the mini splits there to do the heat pump, you can run the mini splits and do all the heating and cooling for most of this months at the most cost-effective way. Run your radiant when it's really cold. And that's not a lot of the heat. This is the amount of heating energy used versus outdoor temperature. So this is from -20 to 65. And you say, wow, when it's really cold, I must use a lot of energy. Well, actually, because of the hours below 10 degrees, which is right in here, use about only 10% of the energy because it's just not a lot of hours compared to all this time. So that's something to put it in perspective. What about the upfront costs? And this is the other dramatic change in terms of upfront costs and the rebates. There's been just, you know, the movement this way. And as Mary says, the evolution. So you get a cold climate, you get $1,000 from Colorado. With new homes, 30% federal tax credit. It's the states are going to administer, and it's going to be dependent on like your there'll be some criteria with income, et cetera, but 2,000 plus. And Holy Cross has 4,000. So you've got a generous rebate there system. Whole house heat pumps are probably the lowest cost still. When you add mini split, you're buying additional comfort and efficiency. And the combos are the highest cost, but actually lower than if you just stuck an AC and a ducted combo in. And also the AC doesn't really help you much up there. And you've got a lot of architectural advantage. And if we just want to do a straight up, you know, it's hard to do all these comparisons. There's so much, but you want to get it to apples, and you say, okay, if I had a furnace AC ducted versus a heat pump, cold climate heat pump with equivalent system quality, efficient. Sometimes these comparisons are apples to orange, like a low efficiency one versus high. The heat pump systems, you know, might be a higher cost on the quotes, but you've got all these rebates. So really upfront cost, very competitive. So let's quickly go through a couple other things, and you're going to all get the slide deck. So I'm going kind of fast, and we'll have questions, but so we're going to talk about how do you get a good systems. There's common things you want to avoid. We'll talk about the specs, sizing, how do you work with a builder, get a contract, get a good quality product. So here's what some of the things that happened in the past. I think now the top one's not really happening as much. Sometimes people would just put in heat pumps and it wasn't really a cold climate. So it'd work down to 30 and be like, well, why isn't my heat pump working? I don't think this happens anymore because the rebates, like Holy Cross and Walking, everyone's rebates are designed such that if you get a rebate, it's a cold climate. This one still can happen. I think it's probably less in new homes because your builder is going to want to have the contractor, but manual J is the common way to figure out how big a heating and how big a cooling, no matter what your system is, boiler, furnace, heat pumps. In the past, sometimes people didn't quite use the correct temperatures for sizing, like the temperature designed for Eagle might be -10. Out near Grand Junction, it might be like -5. Vale, -15. Sometimes, you know, they might undersize things that's poorly installed. And so this is really becoming old. I mean, at some point I'm wondering about the don't work part. I'm not hearing as much anymore. The costs more than expected, but that's changed. So how do you make sure you're getting good heat pump? Well, first thing you find out is the HSPF, and I showed you way back in slide 2, 10 plus and SEER 18 plus. That's a good heat pump. If you look online, you look at their sites, they're going to say variable speed compressor. That's a clue. Great heat pump. Confirm with your contractor. Is it a cold climate heat pump? And mainly the other thing is check that meets the utility requirements. And here's some examples you can read through. When you go on sites, you can say, oh, Mitsubishi, there's their hyper heat carrier, there's Infinite. And then you want to always be a little cognizant for the outdoor units about the specs. Think of air conditioners also getting and heat pumps a lot quieter. They still make noise, and some are better than others. The indoor unit's super quiet, mini splits. Like I've slept in the rooms, you can't really hear. And the warranties are big. So let's talk about size real quick. What size system and how do we figure out sizes? Well, Manual J is the Bible of size. And I talked about, design for the location. When you go into Manual J, it says what town, what city are you in, and it pulls up what you should be designing for. And if your load is between two sizes, always go for the bigger size. Now, past people might have said, no, don't do that because it's going to waste energy. But these are really high-end systems. And remember, I said they could adjust and go up and down. So you want to make sure you have enough heat and it's not going to really. These are the terms you're going to see. Outdoor tons, people talking tons. It's not weight, it's BTUs per hour. 12,000 BTUs per hour is tons. So you get these kind of numbers on the outdoor units and model numbers. So when you see quotes, you'll see this long number. In that will be 024, 030, 36. That refers to that. And this is just a rough guide about, outdoor unit size and what can you think about. How many of the big rooms can it do? How many rooms? And then over here with the mini splits, you have those indoor units around. So it's smaller amount. Little rooms, I hardly need any energy. Bigger bedrooms, a little more. Great rooms, a little more. So the contractor will do this for the outdoor unit. And if they're doing mini splits for the indoor unit, if you're doing ducted or radiant, they'll figure out the distribution system, how much you need for each room. So let's finish up here. Selecting a contractor. So I would say, talk to friends who built new homes with heat pumps. Who are their contractor? Talk to your builder. He's going to normally employ 1 or 2 HVAC folks. One might be more, like, yeah, I've done heat pumps. I'm open to doing all that. Another one might be more hesitant. You can ask how many homes have they done with heat pumps. You can look for their qualifications and are they certified. Oh, a couple more slides, sorry. I know Tim is getting anxious now. Outdoor installation tips. Noise. So think about this. Where you're going to put your unit. It's going to make some noise. And so you don't necessarily, if you're going to hang it on the wall, vibration, I don't want to hang it outside my bedroom. I'll hang it outside the laundry room, the back of the kitchen, other rooms around. But you want to think about that a little bit because it's nice to get it up high in the mountains. And if you're going to avoid or block the west wind, sun helps defrost. You really don't want to put it on the north side. Southeast corner is good. I don't want to go shovel my heat pump out in the winter. Nice cover, get it off the ground, make sure it drains well. I say ask the contractors for pictures and installations or go visit a couple places. This is beautiful. Now, that's really nice. This is really nice. This is not so nice. Duct systems, I'm not going to read through this, but basically they should be really super sealed and insulated. Look at the corners on that. Really nice. You only get, basically this is going to be done once. If they don't do a good job, it's really difficult. They have to be sized to work with heat pumps, slightly different than furnaces, and understand the zoning system. So if you want to have 3 zones in your basement, it might not make sense to put the furnace in the corner of the basement because now you got to have extra ducts to make those zones. So just talk with your builder and think about that. With the mini splits, you think about where to put the outdoor units. You might want to put it more toward the middle of the house if you can. condensate lines are important to each of those little units. And the recessed ceiling units, like those really nice ones, there'll be a little insulation on top and you'll have remote thermostats. So summary, this is happening very fast. I mean, heat pumps are becoming the core component of HVAC systems. Like AC is really pretty much out. It's like heat pump. What kind of strategy do I want to use? And also, you know, radiance in there still also. I should mention that up in, especially in the mountains, not so much in Front Range. You got cooling, you got a lot of options. The big changes are initial cost with all these rebates and tax incentives are basically right up there in par, and your operating costs. And really just think about your goals. Think about, how do I want my house to feel? What rooms are important? What should I do? Work with your builder. And let me, okay, and then I'm gonna unshare here. I'll put this back up at the end. But I'll stop sharing, and then Tim will take over. Thank you.
Thanks, Dave. All right, Tim, do you have your slides?
I hope so. I
And then
hope
we'll
so.
just do the questions at the end. Perfect. Yay.
Yeah.
All right, thank you.
Okay, thank you, Mary, and great presentation, Dave. I'd like to also thank, as Dave has, Walking Mountains and Holy Cross and all the supporters of Walking Mountains and having me here this evening. Again, Mary mentioned I'm with Rheem, been with them 28 years, and I focus on high efficiency products and sustainability, as Rheem has also captured and embraced that. Now, water heating. Water heating represents the second highest energy user in a home. Okay, it's going to be roughly 16 to 18% of all the energy used. And quite frankly, that could represent a significant amount of money used, and heat pump water heating can help you save that money. Now, as a company that represents 65% of all the energy used of the products we make, we have to be very vigilant and provide what the consumer wants, the builder wants, what everyone wants. Okay, so when Mary had reached out to me initially, it was about talking about heat pump water heaters, but also overcoming barriers and misconceptions. And I'm here to tell you that those barriers have been kicked to the curb. You know, heat pump water heaters won't work in cold climate. You know, the way they're designed is that typically there's built-in thermistors that will recognize 37 degrees, which will shut the heat pump down. And the one thing I should tell you is that heat pump water heaters are basically designed to be used in the home, in a conditioned space, not outside. Okay, it's too expensive. With the incentives that are out there right now and the cost savings of the operation of these units, they literally will pay for themselves in less than 2 years. And I will actually show you a slide to that. It's too loud. It's going to make too much noise. It's only 49 decibels when it operates. Now, what's 49 decibels? As I'm speaking to you, that's higher than 49 decibels. Okay. You can see the rest as well. Condensates really, you know, this unit does capture the residual heat of where it's installed. Therefore, we'll have to have a condensate line in order for it to drain properly. But most utility rooms, basements all have those. Now, we introduced our Proterra model back during the quarantine/pandemic. And it was not perhaps, I've been with the company 28 years, as Mary mentioned, the most successful launch we've ever had. A lot of that's timing, a lot of it's need, desire, want. So we based our design on 3 very basic, what I refer to as pillars: smart, sustainable, and savings. Let's talk about smart. Now, we know with water heating, either it's working or it's not working, right? It's leaking or it's just not working. So we incorporated in some of the models leak guard, leak sense detection, integrated Wi-Fi. These units can be connected to your phone. We have a free app that's available through the App Store that you can actually link to your water heater, control the operation of that unit itself. Also, compressor and element indicator. This basically will tell you either your phone or audibly, or you go onto the screen on the unit itself, and it'll tell you, is the compressor working properly? Are the elements about ready? Have they extinguished their life, or how much life do you have left? Okay, so contractors love that. It saves a lot of time, saves a lot of money. And of course, hot water availability. For those of you that have teenagers in the house, you will love this because you won't be the last one in knowing that you're going to get cold water. Sustainability. I mean, we're all as a nation are very concerned about this and have heightened awareness more than I've ever seen. So it's the highest efficient water heater in the country. It does reduce the carbon footprint, which I think we're all in favor for. And of course, energy usage tracking. You can literally go on your phone and you can check on a weekly basis how much energy you're using and when. So you can modify your behaviors in order to save additional money. And of course, Energy Star rated, that's a given. Now, the third pillar is savings. Okay, saves money and energy. Energy saving schedule. You can literally go into this water heater and schedule it to replicate pretty much what your utility has and the way they do their their billing and how they basically operate their business. You can change the temperatures. You have 4 different settings that basically will not be in use. It'll be heat pump only, and again, save the maximum amount of dollars. Built-in demand response. That's really more specific for utilities, but certainly would love to talk to you about that later. And of course, vacation and away mode. I always look at Colorado as a vacation state. It's the most beautiful state I've ever been to. And most people go to vacation there, not away from there. So now we have 3 different models. I'm not going to go over specifics of each, but we do have the builder model. The one thing I want to impress upon you is that we do have a 40 first in the market, and we go all the way to 80. We do have the ProTerra model, okay, that has a variety of different features that the builders, we offered the builder as an a la carte, so you can add a lot of features to the builder model. And of course, the ProTerra model, and then the ProTerra model with the leak guard and the leak sense comes right out of the box that way. Now, how do you size it? Okay, so we've made some national averages, and this is really rule of thumb. A 40-gallon will give you 3 8-minute showers, 50-gallon, 4 8-minute showers, and so on and so forth. The key with these units, they have, much like Dave had explained, you have to be properly sized. Now, here's what I refer to as where the rubber hits the road. The numbers that you see on your initial investment, these are accurate numbers you can find in your market today. Okay, $1,700 for a heat pump. Now, this is a 50-gallon, 30-amp unit. A standard 50-gallon resistor electric heater is roughly about $559. That's not what's important. What is important is the annual operating cost. A hybrid, when sized properly and working in the heat pump mode, is roughly going to cost $95 a year to operate. Okay, and then an electric is about $536. So roughly you're saving 300% to 400% in energy. Now, the units are 10-year warranted units. So over the lifetime of the unit, you're saving well over $4,000, and you're saving $441 per year. Now, there is a federal tax credit available. I know that Holy Cross and Walking Mountains have some programs in place to significantly help you with the initial cost of this unit. So reach out to them and certainly have that conversation. Now, I've also showed you, or I'm showing you here, the energy guides. If you have a Energy Star appliance or any type of appliance in your house, these all come out with energy guides. These are right from the plant. Okay. Now, this is a hybrid against a 50-gallon electric. Look at what the cost is. It's significant savings and yearly annual savings. But I took it one step further. Okay. Not only am I showing you a gas comparison, but also a propane comparison. Significant savings. Now, I put some messaging in here. From a homeowner's perspective, they have immediate information regarding the operation of their unit, okay, on their phone. Sustainability, again, this is where the country's going and much needed, reducing the carbon footprint. And of course, savings, that's a recurring thing through the presentation. Now, user interface. We've made it about as simple as can be in order to operate this unit. This is, if you're standing in front of it, this is what you're looking at. And, you know, basically those are what the buttons are. But what I want to actually spend some time on, in just a brief amount of time, is the modes of operation. Okay, the energy saver mode is the default mode. That's where the heat pump is your primary source of heating, and the secondary are the backup elements in the unit themselves. The heat pump mode, your only pump, delivers 1230 watts to the water, standard ambient conditions. Okay, and again, this unit will operate in the conditions of up down to 37 degrees, up to 145 degrees. High demand mode. You can actually schedule this to run in high demand mode. If you have a lot of people in the house and you know you need quicker recovery, you can put it in high demand mode. And of course, you have electric and vacation. The one thing I want to identify is under the high demand mode or the electric mode, if in event you forget that you put it in that mode, within 10 days, it will go back to the energy saver mode, therefore saving the consumer money. Now, maintenance, very little maintenance is necessary for these units. It does capture the residual heat, so it is pulling in air. So from time to time, you will have to remove this filter. Upon installation, we require 6 inches at the very top, and it is a pliable filter that you can actually bend and pull out, and all you do is vacuum it off or spray it out in the sink or anything you want to do with it and then put it back in. Now, when do you do it? Well, it will give you an audible alarm on the unit, and it will also give you a notification on the phone if you choose to use the app. So it takes the guesswork out of it. EcoNet, that's our term for connectivity. Okay, now this is what you'd be looking at if indeed you download the app. And what I want to spend time on is the scheduling. Okay, you have 4 different time blocks that you actually, if you look at that, and that's a good screenshot right there. You can notice at 8 in the morning, they went to 125, yet during the day when they weren't there, they dropped it to 110. And then and again in the evening, they moved up to 115, and it will stay there. Okay, so you can schedule that. Now, energy use reports, this is what it looks like. And it tells you, there was a big demand in Wednesday. Well, okay, maybe you had someone over the house, but it really dropped off over the weekend. And maybe you've been gone for the day or for the weekend. Now, how do you install these? Okay, if ducted. You can duct these units, by the way. If you don't have enough proper space, it does need 700 cubic feet of usable air for the heat pump to work properly. But if you don't have that, you can duct them. So this is an example of how you would duct them. You can actually duct them. You can go 125 feet, equal feet with both of the vents, provided you have an 8-inch diameter duct. And it's not a very expensive duct, nor is it a real cheap, like a dryer vent. Most HVAC or retailers will have this. And you can actually take your exhaust and move it into another place of the room if you feel that the room is getting a little too cold. These units will actually disperse about 6 to 8 degrees cooler temperature than what it's bringing in. But since most of these are installed in areas that have radiant heat, as Dave mentioned, in the basement, he does very little heating and cooling in there. So you get that radiant heat coming in from the wall. So it recovers very, very quickly. And if the space is big enough, you likely won't even feel it. And I'd be remiss if I didn't recognize that we got the Green Innovation of the Year award from the Green Builder in 2000 last year, and Energy Star partner as well with this product. My contact information is there, and please reach out to me if you have any questions. I'll be glad to answer any questions you may have. Thank you.
Great, thanks so much, Tim. And thanks again, Dave, for your great presentations. So we've got a few questions here. I'll go ahead and start with the first. I believe it's asking about adding a heat pump to an existing home to reduce fossil fuel usage. As you can tell from this presentation, we're more focused on new construction, and we do have other webinars that are focused on existing homes, so we'll definitely share that in our follow-up. But maybe, Dave, could you touch on quickly about how adding a heat pump can reduce GHG, greenhouse gas emissions?
Sure. So I was looking at with an existing. Okay, so if you added it to if you swapped out, I'll do a couple just quick scenarios. If you swapped out a furnace with a heat pump system, basically you end up over the life of the system knocking down the GHG emissions by about 70%. And the way that is our grid right now is, depending on where exactly you are, is like 40 to 50% green. Over the next 7 years, the utilities, 7-8 years, the utilities are going to get up to 75-80%. So in that case, if you're using let's say you have a boiler system and you want to take the second floor and you want to put mini splits in for cooling, and run those most of the year. So you could say, well, maybe that's 40% of your heating bill, and your GHG reduction is going to be basically about 50% of the 40%. So I guess think of it in general, over the next decade, when you're buying a system now, you're cutting your GHGs around 60-70%. So it's a big deal.
Yeah.
It's a very big deal.
And with that question, Dave, because there is a question on and we're hearing this, the refrigerant. So currently R410A is a refrigerant in most, except for like the Sandin, which is a CO2. That's being phased out. And so there's going to be lower global warming potential refrigerants. Do you want to speak on that? Or maybe Sean Lamont from Mitsubishi's on and can maybe talk about when the new refrigerants are going to come?
Well, there's going to be new refrigerants. I'll just say the good contractors, I mean, it's very strict. So there's refrigerant produced in production, but once it's in your house, the refrigerant control by law, like we would have to, if we're going to top up the refrigerant or change refrigerant or do something, we have to capture it. We can't just let it go. We have to capture it, and we had to take it to a place that recycled all the refrigerant. So, I don't really know. I mean, it is a bad GHG emitter. I don't know. I've never studied how much in the production process, but once it's in your house, if you're using proper contractors, no refrigerant should escape when they're working on it. And at the end of life, they're supposed to capture it out and dispose of it properly. So, now the question is, do you wait? And I'm not an advocate of waiting, because you're going to have a huge impact on GHGs by running a lot more efficient system. I mean, the waiting question is always an interesting dilemma. You could wait on any technology, but I think right now, if you weigh it out, it'll be better benefits to just go with it. Now, I should address this. When do you replace the unit? So what's the longevity of the unit? And so this is, because there's embodied GHGs in that. So anything less than 10 years old, even an air conditioner, I'd say, okay, don't throw it away, right? Like, all right, when it's my rule is like over 17 years, like you should change out. Between like 12, under 10, I would say, you're kind of throwing away a good piece of gear. Between 10 and 17, I think it depends like how efficient and good, what quality is the gear you're trying to replace, how much, does it do a lot of your house or little house, etc. So that's another thing to think about. Don't just go running out and throwing away 2-year-old air conditioners. So that's kind of a sort of adjunct to that question. Yes.
Thanks.
Have another question here from John. He's got an existing home with gas with radiant heat and a concrete floor. How do we convert to a solar powered heat pump system?
Okay, so the heat, okay, solar power heat. So solar hot water heating is different than the heat pump hot water heating. I'll address, so heat pump systems called air to water. So the status of the technology is in Europe and Japan, there's many of the top manufacturers make very good, almost plug and play. Everything's integrated. I can have a heat pump that can produce hot water for a radiant in-floor system. The state in North America is that there's manufacturers in Canada, 2 or 3 of them. They're not huge, but they do produce, a few thousand a year, and they work. But in Colorado, we just don't have a big, actually all the Rocky Mountains, we just don't have a big install base. And there's a person, and he's given some talks for this
Right.
series in
Right.
Boulder that does some design work, but there's not a lot of, there's really hardly any installers that do this, just because we just don't have this established yet. I expect in a few years, hopefully, fingers crossed, that some of the big manufacturers will feel that the market is big enough in the US. In lieu of that, what I offer is the strategy of look at your house and say, all right, is there a portion of the house that I want cooling? And I do, it's a big portion of the house. Let's say it's the second floor. Let's say it's 2 great rooms in the main floor, that I can put in a mini split system with maybe one indoor unit, and I can do a reasonable portion of my house heating and cooling that section, which is going to reduce my GHGs. I will turn that zone valve way down, off for most of the year. I will just use it in the middle of the year or in the coldest part when I really want comfort. And that's sort of a way you can think about combining these 2 technologies. Of course, I don't have a super good answer for you, but that's kind of where things are right.
Right.
and-
And
and-
John, we can reach out to John because Hans Brightsense LLC out of Boulder, there is the Arctic heat pump. He actually is designing 2 new homes here that are going to have them. We do have one in Basalt that was a retrofit. So there is a way, if you do have in-floor heating with a boiler, the Arctic heat pump. And John, we can definitely send you that presentation because we did that last month. So Tim, we have a question on heat pump water heaters. And we get this question a lot. So I think it's a really valid question. Does a heat pump water heater take heat from the heated indoor air in the wintertime?
It does. It is installed in a conditioned space, which would be the home. Typically, depending where you live, you may have a basement, you may have a utility room, but it will capture some of that heat. Now, you typically won't feel any reduction of the heat when it's operational, but the exhaust, as I mentioned earlier, is going to be about 6 to 8 degrees cooler than what it brings in. However, you can vent these into a non-provision space if you feel that if you feel it's going to make you uncomfortable.
Yeah, I've actually seen a home vent their heat pump water heater into their wine cooler, which would be a great way of keeping your wine cool.
It's a great idea.
I know. We all need a wine cooler, right, in our home.
Sean from Mitsubishi has a good question. Where do you recommend getting the proper design temperatures for different locations?
Yeah, that's so in Manual J for the different locations, there's it shows the heating design temperature. You could ask your builder to ask his HVAC person to do that. If you have a specific one, you could email me and I could just send it to you. I'm trying to think if there's like a general website that has like just HVAC design temperatures outside of manual J. That's a good question. I'll have to see if there's somewhere online like just a person could go and say, this is HVAC design temp.
Yeah, and I did find something on the Energy Star website. And Sean said that the list that they have doesn't always line up with the jurisdictional requirements, and that it's based on data from 2006, even though it's a 2019 edition. So I guess he was curious if there was a different.
So two options: you can email me if you want, or Sean, or email me and I can look it up and send it to you, or you can, I'd talk to my builder and the contractor, HVAC contractor, on that.
Yeah.
Okay.
So Dave, there's some question, and it's a good question. So the cold climate heat pumps have a pan heater, right? To keep it from freezing. And how much energy? What's that wattage? Is it on all the time? Do we need to go out and empty that pan heater? What kind of maintenance and how much watts? I mean, how much energy is that using?
Well, it's kind of interesting. I can dig out and send you. There's been 2 studies of that. One in the one in Minnesota I'm thinking about. And what they did was they looked at how much, and it was a few percent of the total savings, like I think 5% or something. So it doesn't use a lot. But it's required, it's needed.
Right.
Well, they should set, so I showed pictures of the outdoor unit and the pans and the drain. So you shouldn't have to go out if it's all set up right and done correctly. You should not have to go out in the winter and mess with it. It should be on, it should come on, it should have automatic setting, come on. Some of the manufacturers have this system built into their drain pans as part of it. So it's going to be a few percent. And that's what, they've studied that.
Another question for you, Dave. Can you talk about adjusting the BTUs per hour per altitude for deliver?
I saw those and I'm so appreciative of that question because I did, and I looked and I had that on my slide and it was all on the previous, it was a point of emphasis. So at altitude, since the air is less dense, in order to get the same amount of heat delivered, you have to actually deliver more. So if an outdoor unit's rated at a certain amount of BTUs per hour, a certain amount of capacity, you have to call derated, or you have to say for an altitude, it's basically between 2 and 4% per 1,000 foot. So roughly like 6,000 feet, maybe 18%. So it has 18% less capacity. It varies a bit by manufacturer, but that just gives you a ballpark. So when you're, and I'm going to add it back in the slide, when your HVAC person and your builder designs a system, they have to derate it or lessen the capacity for the high altitude. And with the mini splits, they also have to take that into account for the indoor units too. So you have the outdoor unit, which is delivering so many BTUs reduced, and then the indoor units have to deliver so many BTUs. And sometimes the derating for the indoor units is a little bit less. So the HVAC contractors will know their equipment, and they'll know if it's like 3% per 1,000, 4%, or 2%, based on that. So like Mitsubishi has some numbers in their standards, Daikin, et cetera, et cetera. But thank you, Sean, for pointing that out. That I missed.
He's keeping us honest. He's keeping us honest.
I need to add that. Yeah, that was in all the talks, and all of a sudden I saw the question. I'm like, darn.
Yeah.
So that's very important. And
right. Especially the higher you go, the less air there is. So Tim, that's a great question with the heat pump water heater. Even though these units are inside, do our higher, because I'm hearing that from some plumbers, like they don't work at our elevation. So does the heat pump water heater need to be upsized at 8,000 feet versus 5,000 feet?
No, they're not impacted at all.
Perfect. So it's just you size it by how much hot water you want.
Yeah, typically, comparatively, If you look at a 50-gallon electric heater, it's a regular standard element, a heat pump water heater will actually give you 6 to 7 gallons additional water than that would. So you're going to get a first hour delivery higher than a standard water heater. And again, the high altitude does not impact the unit at all.
Perfect.
Thanks. Another question from Tyler, and I can touch on this a little bit. It's another question about radiant heating. Can a heat pump be used for radiant heating and radiant cooling? Can you talk about radiant cooling in our climate? Again, we had another presentation a couple of weeks ago for air to water heat pumps that can be used in radiant in-floor systems. Currently, air to water heat pump technology is not to the point where it can be used in radiant baseboard heating. But Hans in that other presentation goes into good detail about how it can be used in floor radiant, and he touches a bit on radiant cooling as well. So I don't know if anybody else had anything to add.
Yeah, just the cooling side is he does it with fan coils if you want actually cooling, or the family that has it in basalt, they just cool their floor to about 55 degrees in the summertime, and that's good enough for them. So it just depends on what coolness you want. But yeah, you can do fan coils or just put the cooler water through the tubes in the summer.
Fan coils is the kind of the more advantageous strategy. You can do more things. You can have filtering and stuff. Cooling in the floors, you have to be very careful because you could end up with condensate problems. We looked at that 12 years ago with geothermal because it can do that. So I would be very cautious that I'd go the fan coil.
Yeah. And then, so both like, this is a good question for Tim and Dave. Do you know of any, whether it's a heat pump water heater or a heat pump that are manufactured in the United States?
Ours are, yes. The heat pump water heaters are made here domestically.
Well, I saw that. That's a great, that's a really hard question because it's very difficult to untangle. I mean, a lot of the major brands are relabeled and come out of the same factories in China. So it's really difficult to figure out. There's some brands in Mexico. I think some of Trane, I think some of Carrier. And then there's one other one. There's one made out, what's the big company in Texas? Sort of in my mind right now. I can send you an email on that if you want to just put your email on that. But you're right. I've dug into some of them, like where the units are actually made. And there is a word of caution also for those who are still on the line, if anyone. The internet's becoming more and more about, you'll see all these other labels of mini split heat pumps and very inexpensive. And I would urge caution. And one thing is the warranties. And the other thing is you just don't have people standing behind the units. I mean, you're buying something that's going to last you 15 years. You want them to make parts for 15 years. You want to be able to call the dealer and say, hey, I got a little problem. Can you come out and do this? And if the dealer doesn't know the solution, then there's guys like Sean Lamont, who's the state rep in Colorado, and he'll be out there. And then there's the distributors who are behind their products. So I urge a lot of caution on that. I looked up one, and it was just basically a warehouse in Kentucky they flew all the stuff into and would just sell it to anyone and everyone. So, a word of caution. This is sophisticated technology. It's really good. The better manufacturers really stand behind their stuff, and you want it to last a long time. So just be cautious about all that.
Yeah, great.
All right.
And there's no easy way to find out where this stuff's made. It's just difficult.
Right. Yeah. Yeah. And Sean is saying that Daikin and Goodman and Amana are in Texas, and pieces and parts are manufactured. We know everything runs with a chip, right? We hear about these chips, and a lot of those come from Taiwan and other countries. So yeah, they have to bring, and that's part of the supply chain issue right now. Parts are made in around the world, and then you bring them into the manufacturing assembly line. And a lot of that can be done in the US, but they have to bring in the parts from other parts of the world. So
Yeah, thanks,
there's
Sean. I
time-
couldn't remember. I couldn't remember Goodman.
Yeah.
I kept drawing a blank. Sean,
Yeah.
thank you. Was there any other? I thought Elaine had one really other good question I wanted to address. Maybe it's
So she was talking about the heat pump, and then the altitude, and
ice, yeah,
then
the altitude,
and then
yeah. Yeah, there was one.
So, yep.
Yeah. But anyway,
So if there's any more questions, just it sounds like that might be it. Any last questions, comments, anything? Thank you all
Yeah.
for joining us.
If you got a quick question, just raise your hand and I can allow you to talk as well, if you don't want to type it in.
altitude,
And then
oversize.
Are you gonna show the Love Electric?
Oh, yeah, I
Oh,
should do
yeah.
that.
Or
Alright.
who's
Uh-oh.
got control of the slides? I don't know.
Yeah,
How many-
here's the folks that
Here's our
can help
contact
out.
information. Yep.
Here's
So we're
Love- and
happy to
here's Love
help.
Electric, which has a lot of information,
Mhm. Yeah.
a bunch of stuff. And, you know, and the second slide, when you get it, has Tim and I's emails. I'm happy to answer questions, and I'm volunteering Tim. He'll also answer all your questions.
Yeah, we've got one last one from JP. Looks like it's a pretty specific question about a home that they're designing. And so JP, I would just go ahead and connect you with Dave about that specific question,
Yeah, that'll be good.
and he can help you
Yeah.
answer it offline.
Yeah.
All right.
A lot of new construction going on in our territory. So hopefully we get to
Yep.
see a lot of heat pump water heaters. It's exciting times for all of us here. So,
Yeah.
all right. And Nikki, thank you. There's a lot of stuff being put into the chat. So, yeah. So yep,
Perfect.
we will.
Yeah, Nikki just put that Love Electric website as well as our playlist with all of our recorded presentations. So feel free to check that out. I will go ahead and include this chat because it's been a good chat. I'll go ahead and include that in our follow-up email so you can follow up with links there as well.
Yeah,
thanks
for all the
again.
good- Great questions.
Yeah.
Really good.
Yeah.
Really good.
Yeah.
Thanks, everyone.
Lots of great questions. So thank you everybody for joining us. Thanks
Right.
again to Dave and Tim for your great presentations, and
Yeah.
and thank you, Mary, for helping.
Yeah,
me
you're
host.
welcome.
Yep.
Thanks for hosting.
Thank
Have a
you.
good
Thanks,
evening,
Nikki.
everybody. And
Have
a good
feel
evening,
free to call
everyone.
us with any questions. All right. Take care.
Bye, everyone.
All right. Bye-bye.
Thanks, Sean.